Lesson 7-4, similarities in right triangles. So everything in chapter 7 is always just similarities or proportions. So it's really not that too different from each lesson. So here we're given one triangle, one whole triangle. But technically, if you're looking at this whole triangle, you're actually looking at three triangles. The three triangles you're looking at is on the left, a small triangle here, the small triangle on the right, and also you're looking at the whole triangle. So that's what I'm going to be doing today, and that's the main reason why this might be a very difficult lesson. So here, the first thing we're going to be doing, or that's going to make our lives really easy, is first you draw. What you need to do is draw the triangle separately, right? And then here also draw the whole triangle right after. And what you want to do after you draw it, you want to label what we need to do is label for a small triangle here. For a small triangle, we want to label the parts that represents each of the sides, right? If this A, I'm gonna put A here. If this is B, I'm gonna put B here. If this E, I'm gonna put an E here. After that, what you want to do is you want to label, right? You want to label the parts. This is the short leg because it's smallest side. Furthest side. Here, this is the long leg. How can you determine the hypotenuse again? Here, this hypotenuse because the opposite side of the right angle. Then next, what you want to do is you want to draw the whole triangle after, or the large triangle. The large triangle is, once again, once you draw the large triangle, put down the values that represents each side. E for this side, C for this side, and D for this side as well. So here next is make sure you label the sides to make it easier for you to when you're doing your assignments. Here this is the short leg, this is the long leg, and this is the hypotenuse because once again it's opposite side of the right angle. The last one here, I'm comparing is the whole triangle. Now comparing the whole triangle here, when you draw the whole triangle separately, here you can label down this as A, here label this as D, and here you can do B plus C, or you can just represent it with the whole by representing, which is the value of F. Once again, same thing. Once you draw the whole triangle, what you want to do is you want to write down or label each side. This is the short leg, this is the long leg, and this is the hypotenuse. Why is the hypotenuse again? It's opposite side of the right angle. Just to make it easier for you guys to see the hypotenuse. Yeah. And that's pretty much what we'll be doing today. And I'm gonna be giving you several examples on this. I want to skip this one. I kind of did this with my class, and it kind of confused them. So I kind of want to not do that one here. So here is the first example here. We're going to be trying to solve for. We're going to solve for the value of x. We're going to solve for the value of y. Okay. Once again, to make this easier for ourselves, is we have to once again. It looks easy because this looks really easy because I already have it drawn, but it takes some time for you to kind of draw it and label it. So the big challenge here is just taking the time to draw it and make it easier for yourself. But if you don't draw it, then you'll see how hard it's going to get if you're not really good at observing the shapes. So here, we draw the small triangle here first. Sorry. We draw the first triangle here. Here it has the value of x. Here it has the value of y, x, 4. And here it has the value of y. Right? And here, once again, what I want to do is label this as a short leg, this is the long leg, and opposite of the right angle is the hypotenuse. Next thing I'm going to do is draw the right triangle, or the large triangle, which has the value of y here, and has the value of 12. It doesn't have anything else, so I'm going to leave everything. There's no value here, so I'm not going to force anything, right? I'm only going to label what's given. So here, this is a short leg, because it's the shortest leg out of all three sides, and this is the long leg. It's not the hypotenuse because the hypotenuse is right here. I'm not going to label it because There's no value, so there's no really point. But if you want me to, then I'll just put that. That's extra notes, right? Hypotenuse has no value, but you can still consider it as a hypotenuse. Last thing is, here is the whole triangle here. Here you have the value of x here, and here the whole triangle, if you have a value here, it has a 4 and has a value of 12, then you can put 4 plus 12 is going to be 16 for the hypotenuse. Okay, and that's pretty much how you do the lesson. If you want to separate this a lot more, just so it's easier for you to visualize, you can, right? But the first thing we're going to be doing is solving for x. If you want to solve for y, then it's cool, but usually we're used to always solving for x, right? So here, if we're solving for x, what other part are we going to be using? We want to use the value of 4. The reason why are we not going to use the value of y? Because using two variables is going to be difficult for us, right? And we don't want to use two variables, because that just makes equations kind of difficult, especially if you have another value here that could help us solve it. If you want to use the large triangle first, it's up to you, to make it easier, right? Or here we're not going to be using, for sure we're not going to be using a large triangle. Why? Because we want to solve for x first. Here this has the variable of y. Once again, that's a big clue to not use this triangle. Okay, so what I'm going to do is going to block it off, because it will just confuse us more looking at 3 types of triangles. You're choosing 2 triangles to create a ratio, which is the small triangle and the whole triangle. Why did I choose these 2? For one, I don't want to use the large triangle, because here we're solving for x, right? This does not have a value. This does not. This has a value of variable of y, so I want to use this. I'm going to block this. So here I'm going to compare these 2, and the 2 things I'm going to be comparing is the short leg first, right? This has a short leg. This has a short leg, and here they both have the variable of x. So even though here this both have variable of x, it's still doable, right? Compared to the variable y. So here, the short leg's value here is 4, and here, the short leg's value in the whole triangle is x. Going on to the next one. Here, I'm going to compare the hypotenuse. The hypotenuse of the small triangle is going to be x, and the value of the hypotenuse of the large triangle is, or the whole triangle, sorry, is 16. So what I want to do is I'm going to put this ratio here, which is 4 over x, and I'm going to write down the ratios for the hypotenuse, which is x over 16. I want to be doing, ignore this one here, sorry. And what I'm going to be doing is I'm going to be using cross multiplication to solve for the value of x. Okay. And to do that, here 4 times 16 is 64. X times x is x squared. So here, I'm not going to be teaching you how to do square roots because of the time we have together. So I'm just going to link a video later on today to show you how to do square roots. But for this one, to cancel out x squared, you need to use the reverse property, which is the square root, which cancels out the power of 2. And here, the square root of 64. If you don't know how to do this, you can always just Google it. Or the perfect square of 64 is 8. Okay. Once again, here you can just Google it right away. You can just do this real quick. Go to Google. Hold on. Yeah, I would take the time to teach you how to do the square roots, but since they're really low on time, I can't as much as I want to. So here, the square root of 64 is going to be 8. Okay. Then we're going to be doing the next one here is sorry. New piece of paper here. And what we're going to be doing is solving for y this time. You don't need a diagram above here, since we can just use the diagram that we drew. So here, we're going to be solving for y here. So here, there's what you want to do is you want to either use this or here, this one, right? Here, since this has a long leg here, I'm going to be using the small triangle, right? The small triangle, and in the small triangle, I'm going to be using y is represented by the long leg, right? And also I'm going to use the ratio of the short leg. I'm not going to be using a hypotenuse because hypotenuse value is x, so I want to use the value of the short leg, which is 4. Short leg. And here I need to compare it to another triangle, right? Which triangle has another long leg, and which triangle can I use that can fit both ratios? Here the small triangle's value here is y, and here the short. Can be seen. Here the short's value is gonna be 4. So here, which triangle can I use that has also the same ratio that can be used as the long ratio, complete the long ratio and the short ratio? Here is, I have to use the small triangle and the large triangle. Why the small triangle and the large triangle? Because here I'm using the ratio of the long leg, and I'm going to be using the ratio of the short leg. Looking at the large triangle, it has a long leg, right? Long leg's value is the large triangle ratio. It has a long leg, which is going to be 12. Here, the short leg's value is y as well, which is fine, even though they both have y's, as long as I'm dealing with the same variable, right? Unlike this one here, unlike the whole triangle, which has the variable of x. So here I have y over 12, which is both represented by long leg, and here 4 here, and this y here is both representing the ratios for both of the triangles. So here all you have to do is the same thing, just cross multiply. Y times y is y squared. 12 times 4 is 48. Okay. So y squared, how do you cancel out a y squared? Use a square root. This will cancel out the exponent. And here we have to find the square root of 48. Once again, I already found the square root of 28 here. It's going to be 6.92803233028. Okay. But what I want you to have an answer is your answer is going to be 4 square root of 3. Okay. The square root of 48 is 4 square root of 3. And then here, if you want to write in decimal form, you can write it into nearest hundreds, which is 6.928. Okay, on the nearest hundreds is going to be 6.93. Okay. The reason why I'm really trying to, or this time I'm going to be very kind of emphasizing this part is when you're doing measurements, you want to keep it in this kind of form. You don't want to be rounding it unless it's your final answer. Throughout our lessons or future lessons, we're going to be implementing this in this kind of concept. This is the true answer here, unless they're asking you to round it. Because every time you round it, it loses its true value, right? The true value is the whole decimal. Every time you have the whole decimal, that's the true measurement of 4 square root of 3. And every time you round it, you kind of lose that true value, and your measurements are going to be very, very off. So when you're doing like future math, always keep it as 4 square root of 3. Decimals is when you're gonna just get your final answer. But keep it, for me, keep it as 4 for a 3.